Hey students, today I'm going to be talking about quadratic equations and how to solve them. I really briefly want to go over what quadratics are and how they look on a graph. So I graphed the most kind of basic quadratic, which is y equals x squared. And we have this curved shape on the graph here, which is called a parabola. Looking at this blue equation that I just added, I added another upside down parabola to the graph there, and you can see that a quadratic can look even more complicated than just x squared, but it's always going to be what we call a degree 2 polynomial, which means it has some kind of x squared involved with it. And even the new one that I added, the purple one, is also having an x squared involved because it's inside this set of parentheses that has a square outside of it. And so this x is eventually going to be squared. And we have another parabola that ended up over there. And so parabolas can be upside down. They can be really moved around in any other place in the graph. We're going to look more at graphing parabolas at another time. But today we're going to look at how to solve quadratic equation. So focusing back on that basic y equals x squared equation, if we were to solve for some value, some y value in this equation, for example, if I were to look at when y is equal to 4, I could graph that here, when y is equal to 4, and we can see there's two different places on the graph where y is equal to 4. Specifically when x is at -2 and also when x is at +2. And the nature of that happens to be true most of the time for whatever you plug in for y, just because parabolas have this curved shape. And even if we plugged in some sort of negative value, there could be no solution to when we plug in a value for y. But my point in going through this is that usually when you're solving for quadratics, you are going to end up with two solutions. And we want to keep that in mind when we do our solving by hand next. So we'll start with this first example. We have 6x squared equals 150. And this is a quadratic because we have an x squared involved. And to solve, we want to keep these tips in mind. Remember that your goal is to get x alone on one side of the equal sign. And so we're going to try to isolate it by getting rid of, in this case, both of this 6 and this square right here. And we're going to cancel those two things by doing the opposite on both sides. And then we also need to do the same thing to both sides of the equal sign. So sometimes I'll even draw a little wall down the equal sign to remind myself to do the same thing to both sides. And we have 6 being multiplied by x, and also x is being squared. And we need to get rid of this multiplication of 6 first. And so to cancel that, we're going to do the opposite, which is divide both sides by 6. And so those will cancel each other, and we're left just with x squared on the left-hand side and 150 divided by 6 on the right, giving us 25. So now we can think of, okay, x squared equals 25. What number, when I square it, is equal to 25? Well, some of you may already notice that that is 5. If you didn't know that 5 squared equals 25, you could always take the square root of both sides. This is kind of the rule of thumb. To get rid of a square of something, you need to take the square root, and these two things actually cancel each other out to be left with just x. Now, the thing that's interesting here is, remember before I kept saying that we're supposed to get two answers when we solve this problem. And the square root of 25 actually has two answers. 5 squared is equal to 25, and also -5 squared is equal to 25. -5 times -5 gives me two negatives, gives me the positive, and so there's actually both positive and -5 are our solutions here. And we usually write that using this symbol, plus or minus 5. This means positive, or negative 5. So that plus or minus is basically telling me I had some parabola up here. In my original problem, I was solving for when y was equal to 150, and those two places were at negative 5 and positive 5. Let's try another quadratic here. So I'm going to keep those same rules in mind. I'm going to do the same thing to both sides of an equal sign. And it looks like in this case, I'm going to have to get rid of this 7 and this square to isolate x. Now, since the square is on the outside, I want to get rid of that first. So to isolate that, I need to take the square root of both sides. And those cancel each other. So I'm going to get x plus 7 on one side and the square root of 100 on the other. Recall that the square root of 100 is positive or negative 10. And so how do I solve this from here? Because if we continue to solve, it's a little bit difficult to determine what the answer is supposed to be when you have both a positive and negative 10 on this side. So what I'd highly recommend is actually breaking it into two separate equations. One of your equations has x plus 7 on one side equaling negative 10, and the other one has x plus 7 equaling positive 10. All I did is separate out the negative 10 from the positive 10, and this makes it a little more clear what I'm going to get from my solutions here. So this is just a one-step equation that we have to solve. The opposite of adding 7 to cancel it would be subtracting 7, and so we're going to get x is negative 17 for one of our solutions. And then I also have to subtract 7 in this problem, and we'll get x is equal to 10 minus 7, which is 3. And so this still is a parabola that we had to solve, and our two solutions are at negative 17 and 3. We'll do one last example, and we need to, in this case, get rid of 3 different values. The 4, the square, and the plus 10. And generally speaking, you just want to get rid of the things that are farthest away from x first as a sort of rule of thumb. And I want to get rid of this addition of 10 by doing the opposite, which would be subtracting 10 from both sides. And we'll end up with 4x squared on the left and 36 on the right. And, you know, you really could take the square root of both sides here, because I know the square root of 4 is going to give me a whole number. That's one way to do it. I think I'm going to stick with our previous sort of methodology where we're going to divide both sides by 4, and then we'll kind of take the square root at the end just to make things be a little bit simpler with that plus or minus we'll have to get at the end. So 36 divided by 4 is 9. And then we want to think of what two numbers, when I square them, is equal to 9. Or we can think about taking the square root of both sides. And x is going to be equal to either positive or negative 3. Now, before I end the video, I want to talk about a more complicated quadratic that we have here. If we look at this quadratic and we think about, okay, what can I do to isolate x on one side? Well, I have some issues here. I have an x right here and also one right here. And this one is being squared, meaning I can't really combine these like terms. Maybe if I think about isolating x, I could add 48 to both sides, and I end up with 48 equals, you know, what's left on the right-hand side. But when I have an x squared term and an x term, it's difficult to isolate that. It's possible, but it's difficult. And so with these kinds of situations, you're actually going to want to use the quadratic formula. And because it's hard to isolate x in this. And so I'll talk more about the quadratic formula in our next video.